Hi folks, and Pre-Calculus 1. This is your next video. The video is on rational functions, and we're going to be talking about asymptotes, vertical and horizontal asymptotes. I'm going to try to do this quickly, but you can pause it and listen to it again as you need to. Take notes as you go. This is section 2.6, and we're going to be looking at page 399. But I'll be referring to a couple other pages within the chapter. In order to graph these rational functions, what you have to do is you have to look at whether it has asymptotes. And the first thing that we're going to do when we do this, there's actually a few steps. The book says 7 steps. I actually use 6 steps. I don't do their first step, but we want to find the x and the y-intercept. And you find the x-intercept by setting y equal to 0 and then solving. And if we set y equal to 0, if we then multiply both sides by this denominator, the denominator kind of disappears. So these cancel out, and you just have this. So we have an x-intercept at -3. So that means at -3, 0, there's an x-intercept, which would be right here. Just refreshing your memory because we've done this already. The y-intercept happens when x is 0, and we put a 0 in for x. And this here we get an undefined term, and that means that there is no y-intercept. The next thing we want to do is look for asymptotes. The vertical, horizontal, and a slant asymptote, and we won't be doing this one, at least not just yet. The vertical asymptotes occur when for the x value that makes the denominator equal to 0. So what we do is we take this denominator and we set it equal to 0 and we solve, and that will tell us where we have 2 vertical asymptotes. In order to find the horizontal asymptotes, you could actually look at the rules. They're in a yellow box on page 388. But if we want to find the horizontal asymptotes, we have to look at the degree of the numerator and denominator. If the degree of the numerator is smaller than the degree of the denominator, then there is a horizontal asymptote, and it occurs at the x-axis here. If you notice, the degree here is a 1, and the degree on the bottom is 2. The degree on the top is smaller than the degree on the bottom, so that means we're going to have a horizontal asymptote here. That means our graph is going to hug this line. It's either going to do this or go the other way, but it's never going to touch that horizontal line. There are graphs that part of the graph does go through the horizontal asymptote, but other parts of the graph hug the horizontal asymptote. If the degree of the numerator is bigger than the degree of the denominator, then the function doesn't have a horizontal asymptote. So if that's the degree of the numerator is larger than the degree of the denominator, then you don't have to worry about the asymptote. It doesn't have one, horizontal anyway. And if the degree of the numerator is equal to the degree of the denominator, then we have a horizontal asymptote at y equals the leading coefficients. And I'll show you this one. So this one, the numerator and the denominator have the same degree. So the asymptote occurs at 5/10, which is 1/2. And at y equals 1/2, we have an asymptote up there. So you can look at these again. You can pause the video to see how this all works again, and you'll be doing some examples. So what I'm going to do is number 62 on page 399. And those are the problems you're going to be doing. I'll give you the problems in a few minutes. Here we have a degree the same. So I know, well, let's start off with the x-intercept. Set equal to 0. We can multiply both sides by this here, and they'll cancel out. This times this is just 0. So x equals 0. That means at 0, 0, we're going to have an x-intercept. To get the y-intercept, we put a 0 in for x. And we'll also get that same one as a y-intercept. So now we have the y-intercept. And now we're going to be looking at the next part, part 3. So 1 and 2 was x and y-intercept. Part 3, find the vertical asymptotes by setting the denominator equal to 0. So we're taking this denominator here, setting it equal to 0. We can factor it, factors nicely, set equals 0. These 3 dots mean therefore, if you ever see that. At x equals 3 and x equals minus 3, we have two asymptotes, and I put them in blue. Step 4 would be to find the horizontal asymptotes. And since the degree on the top and the degree on the bottom are the same, it occurs at the leading coefficients, which is 4 over 1. So at 4 over 1, or just y equals 4, right there, this y equals 4 is going to be our horizontal asymptote. That means our graph is hugging these somehow up here or down there. Step 5 would be to find out where it actually is. So in step 5, what we're going to do is we're going to check different points. Points to the left and to the right and in between. In between what? The x-intercepts and the vertical asymptotes. So I want to check a point in between here. And here's my x-intercept, so I'm going to check, let's say 1. Now I can check 2 or 1.5 or anything we want, but 1 is the easiest number to check there. I'm going to check a number in between here, which I'm going to check -1. I'm going to check a number to the right of the vertical asymptote. I chose 4. And I'm going to check a number to the left. If I check these numbers, like I put this -4 into the original function and solve, I'm going to get a 9 1/7. If I graph that, I can see that it occurs way up here at 9 1/7 when x is -4. When x is +4, I also got a 9 1/7. And when I checked here at -1, and you can look through this, pause this video and look through it, I'm going to get a -1/2. And I checked +1, I also got -1/2. This means that our graph hugs these two, but occurs up here and not down here. It could have hugged these two down here. But my graph is going to go through that point, and it's going to hug this asymptote, and it's going to hug this asymptote here. And it's going to do the same thing over here. If I got, say, a -9 1/7 down here, then I would know that my graph was in this quarter over here, and it could also be over here. Now this looks like I have 2 points here in this one, but it's got to hug these two blue lines, so I'm going to go like this, and this will be how my graph looks. You could also use a graphing calculator to check out how this looks too and check your work. So look at this example that I did over and over again, as well as the ones in the book, and then you're going to be looking at page 399. So on page 399, I want you to try all of these, 21 to 43, the odd ones, and 47 to 79, also the odd ones. Some ask for just the vertical or horizontal asymptote. Some ask you to use the steps that are on page 390. I use those 5 steps that I just showed you to actually kind of graph out. And it doesn't have to be perfect. Like, where is it? Is there an asymptote here? And the graph might be going like this. It could be going like this. And you just test points to see where it is. Use a graphing calculator to try to check your work. And then look for further emails that'll tell you when the test will be. I'm thinking the test may be Monday or Tuesday next week. Just a few questions. So practice this. Depend on if you have a Monday or Tuesday class. And they'll be at the exact time that your class meets. So good luck and practice a lot. I will talk to you soon.